Hi everyone. This is going to be our shortest lesson of the year. So nice short video. The Intermediate Value Theorem. It's going to be a very important theorem, but luckily it's really easy to understand and we'll keep coming back to it. But pretty much all it says is that if y is equal to f of x is continuous on the closed interval from a to b, then the value f of a, so whatever the y value is at a, and then f of b, which is the y value at b, the function takes on every value in between. Sounds, as always, sounds a little fancy, so I'm just going to put it in really simple terms for you. We're going to take the line y is equal to x plus 1. So it starts at 1, up 1, over 1. I'm a terrible drawer. Unless I'm connecting the dots, then I do a little better. So I need a lot of dots. So my interval is going to be from 1 to 5. So f of 1 is equal to 2. F of 5 is equal to 6. So by the intermediate value theorem, you are allowed to abbreviate it, both for me and for the AP exam. The function takes on every value between 2 and 6. Why is this important? Well, now I can say maybe those are the only two values you can find on a super complicated function. You can say, well, I know it's 2, then I know it was 6, so somewhere it must have been 4. Somewhere it must have been 5.8. Somewhere it must have been 2.3. By knowing someplace where it is, it lets you narrow down where it must have been. We'll actually do a couple examples just so you can see how it works. Apply the intermediate value theorem to verify the existence of a point where f of x is equal to 0. So you guys know I've been harping on 0 forever. Set it equal to 0 and factor. This is what you usually want. So between 0 and 5. So f of 0 is equal to, if I put a 0 in here, -2. So I'm going to make a little graph. So at 0, I'm at -2. F of 5, it's going to be really big, 125 minus 10 minus 2 should be 115, 113. Okay, I'm not going to graph that. 1, 2, 3, 4, 5, and then somewhere way up here. But since it was at -2, and then I know it reached 113, somewhere it had to be 0. And sometimes that's all you really need to know. I don't need to know where it was equal to 0. I just need to know that it happened. And that allows me to prove that at some point it was equal to 0. Now, could we narrow that down a little bit more? Yeah, that would be great. So it says between what two consecutive integers? The word consecutive means one after another. So 0 and 5 is kind of a broad range. So let's try and narrow it down. I'm thinking I'm going to start with easier numbers. So f of 1, see what it is here. Let's see if it's already crossed up. So 1 minus 2 minus 2 is equal to -3. So at 1, oh, it actually went down. So it went down before it went back up. F of 2 is 8 minus 4 minus 2 is 2. There we go. At 2, it's 2. So this graph went somewhere down, but then somewhere up. So now I know that f of x is equal to 0 between x is equal to 1 and x is equal to 2. So I figured out between what two consecutive integers f of x was actually equal to 0. So yeah, it happened on the broad spectrum, 0 to 5, but they're usually going to want you to narrow it down. And that's called the intermediate value theorem. Somebody gave a fancy name to the concept of, well, if I saw it was negative and then it was positive, it must have been 0. But we will use that concept a lot this year, so now you know the name of it. Okay, if you are in the honors class, you can sign off and cross off number 2. You do not need to know how to do this one. You're welcome to stay on and listen if you want. Is there any real number that is exactly 1 more than its cube? This is an interesting problem that shows you how sometimes people are just trying to prove something. They don't want an answer exactly. They just say, could this even happen? So is there a real number, x, that is exactly 1 more than its cube? That's how you would translate that. You're saying to me, is this a mathematical possibility? And of course, when you first look at it, you say, no. I mean, if you cube a number and then add 1, it's definitely going to be bigger than the original number. Anybody have an idea? If x is a fraction, if it's something small. So if x was, say, 1/4, 1/8, 1/16, when you cube it, it just gets smaller. And then you add 1. Is that going to work? If you're not sure, this is where the intermediate value theorem comes in. It's usually easier to make it equal to 0. Is there a point at which, so I'm going to write this, ask instead, is there a point where x cubed minus x plus 1 is equal to 0? And then it's so easy to prove. If you can find a point where this function, we'll call it f of x, is equal to a negative number, and then you can find another point where f of x is equal to a positive number, then you have proven that at some point it's equal to 0. So you can go ahead and try that on your own. It's a little bit of guess and check. I could pause it for you. Hopefully some of you tried a few, but I will tell you that I used f of 1 is equal to 1, and f of negative 2 is negative 5. 1 and negative 2 are not consecutive. That's okay. The question just asked, is there a point? Is there a real number that it's 1 more than its cube? Well, this is only true if this is true. And this was much easier for me to prove. So I can prove that it's equal to 0 at some point by the intermediate value theorem. This function is equal to 1, and at negative 2, it's negative 5. So somewhere it has to actually be equal to 0. You could find the consecutive numbers, but it doesn't ask for that. There you go. Shortest lesson, intermediate value theorem. I'll see you next time for what is literally my favorite lesson of the year, rates of change in tangent lines. See you next time.